Right, good morning. Today we're going to look at ionic equation. How do we write ionic equation? What is an aqueous solution? And then along the line, I will discuss briefly what we mean by solvation. That is, how does the salt dissolve in water?
An ionic equation is a chemical equation involving ions. Ionic reactions require at least two reactants.
Sodium chloride is soluble in water. Solid sodium chloride, when dissolved in water, breaks down into sodium ions and chloride ions.
Sodium chloride. Added to water. And stirred leads to the dissolution of sodium chloride with the formation of sodium and chloride ions in solution.
This is represented by the equation. This equation is called the Ionic equation.
All right, let me explain briefly what happens in the solution because you need to know the diagrammatic expression of this. Now, sodium chloride, it's ionic bond, so it has sodium ion and chloride ion. Now, water, in its own case, has this structure, right? This is partially negative, partially positive. So in the presence of this sodium chloride, what happens? How do they separate? How are they dissolved? Now, the orientation is like this. Sodium that is positively charged, ion, that is a cation, will be in the middle of water. So molecule of water will surround this molecule of, let me use this white. So this positive ion is being pulled away by negative of oxygen. Okay, so all these water molecules will surround sodium and pull it away. The chloride ion, in its own case, is going to be this way. This will be the orientation. You can see that for chloride ion, the hydrogen, which is the positive, partially positive, is the one that is closer to the chloride ion, just like you have it here as well. So this is the orientation of how the salt dissolves in water. So molecule, the ions of sodium is being pulled away by water molecule, just like this. Sodium ion in the center with water molecule oriented in this form. The hydrogen side of the water molecule is the one towards the sodium, so that positive and negative can attract, and then they pull this away, while the sodium ion, the chloride ion that is negatively charged, is being pulled away by hydrogen ion that is partially positive. You see the orientation is not the same thing as this. So the negative side of sodium chloride, which is the chloride ion in the center, with the hydrogen oriented towards chloride. And that is how you draw the dissolution of salt. This is how every solution, every compound that dissolves in water are separated. Those are these two orientations that you need to know. Look at water. The ion is in the center. They are surrounded by molecules of water. So it depends on the charge of that ion for you to know how the orientation is going to be. All right.
Silver nitrate is soluble in water. Solid silver nitrate, dissolved in water, breaks down into silver ions and nitrate ions.
Here we have crystals of silver nitrate. Added to water, now stirred, causes dissolution of silver nitrate and the formation of silver and nitrate ions in solution.
I'm trying to draw the structure of how this is also separated. This is water molecules surrounding, you have silver nitrate, and the positive side of silver nitrate is silver. So the Ag plus will be in the middle because hydrogen is here, hydrogen is here, hydrogen is here, which are negative. So this will be in the middle, while the O and O and O of this will be the one facing the silver. Then the other one will be the other way around, where nitrate will be on this side of the other set of water. Let me have that one drawn here. So in this case, it's going to be H, H, O, H, H, O, H. So in the center here will be the sulfate. This is a different color. See that? So this is the negative in the middle, and then the partial positive hydrogen, partial positive hydrogen, partial positive hydrogen surround the sulfate. And that is how sulfate ion is being pulled away. So all this will move away, and this one also move away. So it's like this goes this way, this one goes this way. That's why silver nitrate dissolves in water. Okay. Now, if this is possible because silver nitrate is polar. It has a positive and negative charge. But in a situation where you have a non-polar liquid, just like you pour gasoline in water. Gasoline doesn't have polarity, so there is nothing to pull apart. Water will just be roaming around looking for a positive or negative end to pull, but there is none on gasoline. That is why gasoline will not dissolve in water. Polar, this is polar, and gasoline is non-polar. So they will not dissolve in each other because the rule is polar dissolve in polar and non-polar dissolves in non-polar. All right?
This is represented by the equation. This equation is called the Ionic equation. The Ag plus aqueous combines with Cl minus aqueous to produce AgCl. From the solubility rules, we know AgCl is insoluble in water. Insoluble salts in an ionic reaction are called precipitates.
Sodium chloride solution on the left, silver nitrate solution on the right. An aliquot of the sodium chloride solution is withdrawn and placed in the silver nitrate solution, and a precipitate is observed to form.
Hence, AgCl appears as a white precipitate.
The Na plus aqueous combines with NO3 minus aqueous to produce NaNO3. From the solubility rules, we know NaNO3 is soluble in water. Hence, it will exist only as Na plus aqueous and NO3 minus aqueous.
All right, one more thing I want to point here is when you dissolve salt, sodium chloride in water, some people will expect that, oh, okay, why is the water in the final equation? Because you dissolve salt in water and we didn't see any water written in the equation. Yes, we don't really normally write water in that situation because this aqueous represents the fact that the salt has been dissolved in water. Sodium chloride will not dissociate by itself except when it is dissolved in water. So anytime you see aqueous, remember that water molecule is also involved. It was dissolved in water before they can put aqueous there. So you don't need to put the product here as water or whatever you want to put. No, you don't need. Once you have aqueous, it shows that your solution here is already dissolved in water. You can see that when salt dissolves in water, you have salt solution, which is called aqueous. So that aqueous stands for presence of water. Take notes.
In a sodium nitrate solution, sodium and nitrate ions are spectator ions in solution.
Thus, the overall ionic reaction is this equation is defined as the complete ionic equation.
The Na plus ions and NO3 minus ions are called spectator ions. The spectator ions are canceled from both sides in the overall ionic equation.
The resulting equation is, this is the net ionic equation.
Cobalt Roman numeral 2 chloride and sodium sulfide solutions are mixed. Decide if the precipitate forms. Identify the spectator ions. Write the complete ionic and the net ionic equations. Cobalt Roman numeral 2 chloride is soluble in water. Solid cobalt Roman numeral 2 chloride, when dissolved in water, breaks down into cobalt ions and chloride ions.
Cobalt 2 chloride crystals. Added to water. dissolve, giving cobalt 2 and chloride ions in solution.
This is represented by the equation. This equation is called the Ionic equation.
Sodium sulfide is soluble in water. Solid sodium sulfide, when dissolved in water, breaks down into sodium ions and sulfide ions.
Sodium sulfide crystals, added to water, dissolve, giving sodium and sulfide ions in solution.
This is represented by the equation. This equation is called the Ionic equation.
The CO plus 2 aqueous combines with S minus 2 aqueous to produce COS. From the solubility rules, we know COS is insoluble in water. Insoluble salts in an ionic reaction are called precipitates.
An aliquot of cobalt 2 chloride solution on the left is added to sodium sulfide solution on the right, resulting in the formation of a dark precipitate.
Hence, COS appears as a black precipitate.
The Na plus aqueous combines with Cl minus aqueous to produce NaCl. From the solubility rules, we know NaCl is soluble in water. Hence, it will exist only as Na plus aqueous and Cl minus aqueous.
Sodium ions and chloride ions are spectator ions in solution.
Thus, the overall ionic reaction is. This equation is defined as the complete ionic equation. The Na plus ions and Cl minus ions are called the spectator ions. The spectator ions are canceled from both sides in the overall ionic equation. The resulting equation is, this is the net ionic equation.
Sodium chloride and calcium nitrate solutions are mixed. Decide if the precipitate forms. Identify the spectator ions. Write the complete ionic and the net ionic equations.
Right, pause the video and let's work it out.
Sodium chloride is soluble in water. Solid sodium chloride, when dissolved in water, breaks down into sodium ions and chloride ions.
Sodium chloride, added to water, and stirred, leads to the dissolution of sodium chloride with the formation of sodium and chloride ions in solution.
This is represented by the equation. This equation is called the Ionic equation.
Calcium nitrate is soluble in water. Solid calcium nitrate, when dissolved in water, breaks down into calcium ions and nitrate ions.
Calcium nitrate crystals. Added to water, dissolve. Forming calcium and nitrate ions in solution.
This is represented by the equation. This equation is called the Ionic equation.
The Ca plus 2 aqueous combines with Cl minus aqueous to produce CaCl2. From the solubility rules, we know CaCl2 is soluble in water. Hence, it will exist only as Ca plus 2 aqueous and Cl minus aqueous.
Sodium chloride on the left, calcium nitrate on the right. Aliquot of sodium chloride withdrawn, added to calcium nitrate, results in no precipitate.
Now, there is a reason why there is no precipitate because they are all soluble. So if you check your solubility rule, you see that all nitrates are soluble. So that means calcium nitrate is soluble, sodium chloride is soluble, and then sodium nitrate is soluble, calcium chloride is also soluble. So you will not see any reaction. This is the situation where you mix the two substances together, you didn't see anything. Nothing happens to you. You didn't see any changes. But they are all spectators, they were all moving around in the solution, and there was no reaction.
Note there is no precipitate. The Na plus aqueous combines with NO3 minus aqueous to produce NaNO3. From the solubility rules, we know NaNO3 is soluble in water. Hence, it will exist only as Na plus aqueous and NO3 minus aqueous. The overall ionic reaction is. Hence, the overall balanced ionic reaction is. This equation is defined as a complete ionic equation. Note, in this reaction, no precipitate forms.
Thus, the overall conclusion is no reaction occurs.
Copper, Roman numeral 2, nitrate, and sodium hydroxide solutions are mixed. Decide if the precipitate forms. Identify the spectator ions. Write the complete ionic and the net ionic equations.
All right, that is the question for you to practice. I'm not going to give you the response. Just go ahead and pause the video and do the practice.
Cobalt Roman numeral 2 chloride and potassium hydroxide solutions are mixed. Decide if the precipitate forms. Identify the spectator ions. Write the complete ionic and the net ionic equations.
All right, this is another question. Go ahead, pause the video, solve the Ionic equations problem, and understand all the steps. Right, I'm going to stop right here to the next period again. Thank you.